Ritual Lab at University of Houston. In my research, I'm mostly interested in applying natural language understanding techniques into design and text formatting applications. Um, in the past few years, I had this opportunity to work with amazing collaborators from Adobe Research, and today we're extremely excited to be holding this workshop. Um, in this session, I will talk about the shared task that we organize as part of this workshop. Firstly, I'm going to introduce the task, and then we're going to listen to the top performing team's presentation. Um, I'd like to start with an example here. I'm showing two slides, basically with the same content. Um, as you see, the one in the left is plain, while the one in the right uses different special formatting to emphasize salient content in the slide, which makes the slide readable and easier for audience to process. Um, in this talk, I'm going to start with introducing the task, which is emphasis selection in presentation slides. I'm going to talk about the characteristics of the task. Then I move to the shared task. I define the task, the data set we use, and finally introduce the top performing models. Um, as we all know, presentation slides have become a common addition to the teaching material. Um, in the past few years, we have seen many studies on automatic slide generation. There are from different types of documents, such as um, scientific articles, for example. However, few have addressed automatic design assistance during the authoring of the slides. Um, such content-aware design recommendations or assistance can potentially enhance the slide's communication power, and also it can improve the visual appeal of the slides. So the goal of this shared task is to essentially predict emphasis words in presentation slides. Um, and by emphasis, we mean the use of special formatting like boldface, italics, using different colors to make words stand out. Um, and the the outcome would be a well-designed emphasis that can potentially um, uh, guide viewers' focus on few words instead of reading the entire slide. Um, audience can retain their attention to the speaker during the whole presentation. Uh, the task of emphasis selection in presentation slide is challenging. Um, the reason I'm saying that is because slides can have different structures, and authors may follow traditional slides, as we all know, like bullet points, or they can go with more modern styles, such as having more visual content and less text. Um, the other the other one is that slides cover a wide range of topics. So from technical, marketing, legal presentations to even children's illustrations. And this requirement to generalize to different domains and cover a variety of topics poses new challenges uh, and encourages developing robust language understanding models. Um, the the third characteristics is uh, is uh, is that we only rely on the input text for suggesting emphasis. This task is subjective, but the goal is to embed natural language understanding uh, to basically discover the most common interpretation of one slide page and generate emphasis that makes the page easier to understand. Uh, oh, this is how we define the task. So given a sequence of tokens in one slide, from like x1 to xn, the task is basically to compute a real value from 0 to 1 for each word in the slide. And that value indicates the degree to which each token needs to be emphasized. As part of this shared task, we introduced a new data set. This data set is basically a collection of presentation slides with a wide range of wide range of topics. And in order to have a wide range of topics and areas, we collected data from different sources, such as, for example, ACL, Anthology, or other websites, for example, with non-technical content. We also annotated data in an MTurk experiment. Um, what we did was we asked workers to select words that need to be emphasized, and as if they prepared their slides for their own presentation. And in the experiment, we showed the image uh, of the slide as well as the corresponding raw text. We followed many pre-processing techniques to make sure that we get the clean text. We remove those that contain tables, formulas, and or equations. Here, I'm showing an example of the data. Uh, so here is basically an example bullet point along with emphasis probabilities. These are our 8 annotations. We use the BIO scheme. That basically B indicates the beginning, I indicates the inside, and O indicates the non-emphasis words. In the third column, we show the frequency of this BIO. And the last column that we call it emphasis probabilities shows the, the, the probability of each word that needs to get emphasized. And we use this value to as emphasis probability and to evaluate different models. As you can see here, words like risk and management have there is more agreement to emphasize those in this bullet point. Here I'm showing some statistics of the data. So the data set contains 1,776 high quality slides, and they're randomly split among 70% for training, 10% for development set, and 20% for test set. And here also I'm showing some statistics on the length of the samples, number of tokens that range from like 13 to 181. Here we have some analysis in the data. So many handcrafted features such as punctuations or uppercase tokens help improve many of the models in the shared task. And knowing that motivated us to examine the degree of emphasis probabilities for different lexical features, basically. So here, what I'm showing is the average emphasis score for each lexical feature. Uh, and as you can see, uh, um, words with uppercase start uh, have higher emphasis probability compared to punctuation, for example. And knowing that, I mean, that indicates some general trends for emphasis with respect to word categories. The other analysis that we performed was on part of speech tags. So basically, we chose the top 20 part of speech tags, um, which frequently occur in the training and development set. And we try to analyze the features effectiveness. We observed that like part of speech tags like uh, dot, in, comma, column, they're more favored to have low emphasis probabilities. As you can see, they fall into 0 to 25. And some part of speech tags like nouns and verbs, they have more emphasis probabilities. Okay, so as evaluation metric, for the evaluation metric, we used match-m, uh, which uh, which was used before in the previous emphasis selection task. And we compute this score for top 1, 5, and 10 words or tokens. And as for the baseline, we used the BioSTEAM Ilmu model, which is basically a sequential tagging model that uses KL divergence loss during the training. Here, I'm showing the systems, I mean, the list of teams, the models, and also all the scores. We rank the teams based on the average value of match M, we call it rank. And we, we've seen like a wide range of solutions to tackle this problem, basically, but I'm not going to the details right now because we're gonna see the presentations. Um, yeah, so we we're gonna learn about these models later. We also perform an error analysis to examine how the length of slides can affect the prediction. We used the average scores over all submissions for computing the performance, and essentially we divided the test set into three groups: short, medium, long, and basically the results show that longer slides are more challenging due to having more options to select. And finally, in this short task, we provided research on a novel NLP task. We received many participants from both academia and industry. Um, we also observed diverse, interesting sets of solutions to model emphasis and presentation slides. And thank you so much. I'm going to stop.